So last lesson we did the problem solving part, the mixed review problem solving. For 8C, we were able to get up to question 2, and 8D, I think we went up to question 4. So if you're in 8D, you can skip past question 4 and just start from question 5. And then for 8C, you need to watch everything starting from question 3 over here. So if you haven't finished all of the problem solving questions, please go ahead and finish all of them first. So up to question 8, please do finish all of them first before you check your answers. So starting from question 3, Joe has a new home security system with a 3-digit entry code. So what does that actually look like? So 3 digits, so there's 1 digit over here, there's 2 digits over here, and there's 3 digits over here. And then he remembers that the first digit is 4, but not the rest of the code. So first of all, if he remembers the first digit is 4, we're going to go ahead and lock in that 4 over there, so we don't have to think of the possibilities for the first number. And then we're going to guess, look at the number of possible numbers for these two. So for this number over here, it can be from 0 to 9, so there's 10 possibilities. And then for the last one, again, from 0 to 9, there's another 10 possibilities. So once we multiply them together, there are 100 possibilities if Joe knows that the first number is 4. Now, what is the probability that he guesses it correctly in a single attempt? So in a single attempt, he's going to guess one number and one number over there. And so the probability of him, so probability of correct the first time, well, there's only one favorable outcome. So that's one favorable outcome. And then the total possibilities will be 100. And so as a decimal, that's going to be 0.01. And as a percentage, that's going to be 1%. Moving on, question 4. You have 4 shirts and 3 pairs of pants. Explain how the number of outfit changes if you buy a new shirt. So first of all, you have 4 shirts and 3 pants. What are the possibilities? So 4 times 3 will give you 12 possibilities for shirts and pants. So this is question 4. And if you buy a new shirt, so now the number of shirts you have, you can choose from 5, you can still choose from 3, and that'll be 15. So it changes by 3. So you have 3 new outfits in total. So that's question 4. Question 5. So everyone should be listening for this one. A box contains 5 numbered dices that have 4, 6, 8, 12, and 20 sides. So in this box, there are 5 dice. It doesn't say that they're the standard number cube. Instead, one of the dice has 4 sides. One of the dice has 6, that's the standard one. One of them has 8, one of them has 12, and one of them has 20 sides. So each one has sides labeled with consecutive whole numbers starting with 1, which means that the first dice, so dice number 1, that's the 4-sided. Actually, I'm going to label the dices. So the 4-sided dice can have possibilities from 1 to 4. And then we have a 6-sided dice, 6-sided. And so the possibilities for the 6-sided will be from 1 to 6. Then we have an 8-sided, 8-sided. And the possibilities for the 8-sided dice will be from 1 to 8. And then we're going to continue. We have a 12-sided and also a 20-sided, in which the possibilities for this one will be from 1 to 12, and this will be from 1 to 20. So how many possibilities for this? That's going to be 4. That's going to be 6, there's going to be 8, there's going to be 12, and that's going to be 20 total possible combinations, not exactly combinations, but total possibilities if you roll all 5 dices together. So let's go back to our question. Sorry about the screen flickering. Okay, we're back to normal. So Felix selects one of these and rolls it 60 times. He selects one of these. Yeah, so he selects one of these and rolls it 60 times. The number 3 comes up 13 times. Which numbered die did Felix most likely select? Okay, so he rolls it 60 times and it came up 13 times. So the number 3, let's say number 3 occurred 13 out of 60 times. 13 out of 60 times. So if we were to change that into a, let's change that into a probability, into a percentage, sorry. So out of the 60 times, he rolled it 13 times. So 60, so 13 divided by 60 will be 0.217. That's the same as 21.7% of the times. Okay, now we want to look at each one of these dice over here. So we're actually not looking at the total possibilities this time. If we were to look at what is the possibility of rolling the 13 times, from a four-sided dice. So the possibility for this, let me now move these down here. I want to actually take these, and then I'm going to move this down here instead because we're going to need that. So for the four-sided dice, okay, for the four-sided dice, the number 3 will occur 1 out of 4 times, which means that if I roll it 60 times, then the number of times that it should occur would be 15 times. Then if I had the 6-sided dice, there should be 1/6 of the time we would get the number 3. So multiply that by 60, that will be 10 times. And then if it's an 8-sided dice, it's going to be 1 out of 8 chance of getting the number 3. Multiply that by 60. 60 divided by 8, we will get 7.5 times. And then so on. Let me just quickly continue. 12, and then we also have 20. So each one of them each one of them has a 1 in 12 chance and a 1 in 20 chance of rolling that number 3. So if we divide that by 60 or multiply 1 over 12 times 60, that's going to be, we're going to expect the number 3 to appear around 5 times. And then for 60, it's going to appear around 3 times. Now let's go back to our question. It says, let me bring all of this back up to the correct place. So, the number 3 comes up 13 times. So that is around, so 13 times, which one is closest to 13 for this one? So that's roughly, that 21% is actually closest to the 1 in 4 chance, which is the four-sided dice. So 13 is closest to 15. So the chances of it being four-sided is the most high. Okay. The last part, can we answer this question with certainty? No, we cannot answer this with certainty because it could just be that we were so lucky in the 12-sided dice and we just happened to roll it 13 times in that 20-sided dice. So there's always chance that happens. Question 6, let's continue over here. We're almost there. So a Locker combination has 3 one-digit numbers. Okay, a Locker combination has three one-digit numbers. So 3, 1, 2, 3. And so if the digits can repeat, what is the probability that a randomly chosen combination will not have all the same digits? So we want one to be not the same, but it could happen in this dice. So first of all, if we think about this, if the total possibilities, let's look at the total possibilities first. So total possibilities. So in this 3 digits from 0 to 9, 3 one digits, they can repeat. So it could be 10 times 10 times 10 equals 1,000 possibilities. So in this locker combination, there are, possibilities. There are 1,000 possibilities. Now, let's look at the number of possibilities in which the numbers do not repeat. They do not repeat. That means, for example, if I chose a 1 for the first, if I chose 1 for the first digit, it's going to be not 1. So the number of possibilities now become 9, and then for the next one, it will be 8. So now our favorable events will be the first number can be any number because one number on its own can't repeat by itself. So that's 10 possibilities from 0 to 9. And let's say, for example, we just took a number and that number was 5, for example. So our second number cannot be 5 now. So what are the number of possibilities now? 0, 1, 2, 3, 4, skip 5, and then 6, 7, 8, 9. That's going to be 9 possible outcomes over there. And so for the last one, if we had one number chosen for the first number and a second number chosen, and that number cannot repeat, those two numbers cannot repeat, how many possibilities are left? That has to be 8 possibilities. And so for the favorable events, it's going to be 10 times 9 times 8, which is 720 possibilities. Whoops, t's. And so this 720 possibilities are in which the numbers do not repeat each other. So we don't have a 111, or we don't have a 222, or a 112, and so on. They're all different. So it's still quite a lot. And so the chances, okay, so what is the probability that a randomly chosen combination will not have all the same digits? Okay, not have all same digits is 720 possibilities. So our probability of no repeats will be 720 out of 1,000. And so that is the same as 72% chance. So that's quite a high chance because it's more likely for you to choose a number that doesn't repeat itself than for it to repeat itself. Okay, now getting on to question 7, let me just quickly bring these questions down. Whoops. Nope. What am I doing? Question 8, I'll move that down. And let me move question 7 down so that we can see. Good, question 7. So you want to redecorate your bedroom with one new comforter, one pair of curtains, one rug. Your color choices are shown in the table below. So for comforter, we can have 4 choices. Okay, so for the first one, we have 4 choices. For the curtains, we have 3 choices, 3 over there. And for the rug, we also have 3 choices, white, tan, and blue. And so let's look at our question over here. Use a tree diagram to show the number of different ways you can redecorate. So it does say we have to use a tree diagram this time. So for comforter, we can have white, we can have tan, we can have blue, and we can have gray. So that's where our tree starts, white, tan, blue, and gray. And then for the curtains, let me just quickly draw some dotted lines so I don't go over. Now within this, for curtains, I can have white, blue, or gray. So it's going to be white, blue, or gray. And then rug, we can have, white, blue, and gray. And then so this is also white, blue, and gray, white, blue, and gray, and white, blue, and gray. And then for the rug, okay, we can have white, tan, and blue. So each one of these will further span out. I'm going to have to zoom in even more. So there's going to be white, tan, and blue. So white, tan, blue, 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 white, tan, blue. I'm running out of space. White, tan, blue, white, tan, blue, and lastly white, tan, and blue. So that was fairly complicated there. Forgot to span all of these out in our tree diagram. So let's now look at the question. B, use the counting principle to justify your answer in part A. Oh, so we're supposed to count. So that's going to be 3, 6, 9, 12, 15, 18, 21, 24, 27, 30, 33, and 36. So there's altogether, there's 36 possibilities. Different ways, 36 different ways. So that is part A. And now for part B, we want to use the counting principle. That's going to be 4 times 3 times 3. And so put 4 times 3 is 12. 12 times 3 is 36. That's equal to 36. Which way is faster? Counting principle, so much faster. Now let's move on to part C. Suppose you choose one of each item at random. What is the probability that all 3 items are the same color? Now, for this question, it would help to have that tree diagram. Or what you can do is you can list out the possibilities in which all 3 are the same color. So there's 2 different ways you can do this. Either you can use your tree diagram and just highlight white, white, white. So that is all 3 same colors. There's no tan curtain, so we can skip out tan over here. And then for the blue over here, there's going to be blue, blue, and blue. And then for gray, there is gray, gray. Oh, there is no gray. In fact, there's no gray rug. So again, we can skip out the rug. So how many possibilities or how many ways in which there are all 3 same colors? There's only actually 2. So the probability of all same color is now 2 favorable events out of 36, which is the same as 1 over 18. And so change that into a decimal. That's going to be 0.056, which is the same as 5.6% chance. So that's a fairly small chance. Last question, question 8. So you are going to distribute 6 rocks you have collected on the beach into 3 boxes, which are blue, green, and orange. If each box gets 2 rocks, in how many ways can you do this? So let's look at this. You have 6 rocks, 1, 2, 3, 4, 5, 6, and then you have 3 boxes, which one is blue. So the first one is blue box, the second box is a green box, and orange, I'm gonna have to choose an orange color. Whoops, let me make this slightly thicker, and orange. Good. So now, in how many ways, if each box gets 2 rocks, in how many ways can you do this? So first of all, let's think of these rocks as numbered rocks. So there's going to be number 1, number 2, number 3, number 4, number 5, and number 6. There's no way 2 rocks are exactly identical. So you can put these rocks into it in different ways. So think about it. We can do this in, we can have 1 and 2, we can have 3 and 4, and we can have 5 and 6. That's one way. How else can we do it? We can have 1 and 3, we can have 2 and 4, and then we can also have 5 and 6 this way. So again, there's a lot of possibilities. Now, if we think about how we can put the rocks into the first box, first of all, this box, how many ways can we put the 6 rocks? There's choose 2 of those rocks. So if we think about it, we can have 1, 2. We can have, let's list out some possibilities. So we can have 1, 2. We can have 1, 3. We can have 1, 4. We can have 1, 5. We can have 1, 6. No problem there. We can also have 2, 3. We can have 2, 4. We can have 2, 5. And we can have 2, 6. And then if we think about it again, we can have 3, 4, 3, 5, 3, 6, and then we can have 4, 5, and 4, 6, and then we can have 5 and 6. So how many possibilities for the first, how many different events for the first box? That's going to be 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, and 16. So the first one will have 16 possibilities. Now let's just say I've put I've put in 2 rocks into the first box now. So for example, if I put 1, 2 into the first box, how many are remaining? There's only going to be, so now if I put 1 and 2 into the first box, there's only 3, 4, 5, and 6 left. So let's think about it this way. How many possibilities are there for 3, 4, 5, and 6? We can have from 3, 4, 5, 6. Let me just circle from 3, 4, and 5, 6. So we can have 3, 4, 3, 5, 3, 6, 4, 5, 4, 6, and 5, 6. Now, how come I didn't choose any of the ones previously? Well, if I did 2, 6, well, 2 was already in that first box, 1 and 2. Same as over here, 1 and 6, 1 is already in that box. So I'm only counting 3, 4, 3, 5, 3, 6. So that's how many possibilities now? So 1, 2, 3, 4, 5, 6. So that's 1, 2, 3, 4, 5, and 6. So now there's 6 possibilities that go into the green box. So let's say that, we've chosen 3 and 4 that go into the box. Now, how many possibilities now for the last box? There's only 1 left because there's only 5 and 6 that we can do it that way. We cannot choose any more because that's the only 2 rocks that are left. So now let's multiply them all together. So what are the total possibilities? That's going to be 16 times 6 times 1, which is 96 different ways. 96 different ways. So I know this question can be a little bit complicated. I want you to think about it in, that you have numbered rocks, 1, 2, 3, 4, 5, 6, and then you're going to put them into the 3 different boxes. How many different ways can you actually do it? So think about the first box first. And then once you've got the first box down, then you think about the second box, and then you think about the last box. Okay, so hopefully you have tried your best to do all the questions, mark your own work, and I will see you all next lesson tomorrow.